Hello everyone, welcome to our channel Simple Physics and Chemistry is SP and C. We are doing some calculation on electrostatics. So this is our next video on electrostatics where we are showing like two charges are kept, one is positive and negative, and the force in between them are known, that is 0.2 Newton. So what we have to do here for this problem, we'll try to find out how much distance they are. Okay, so we have to find out the distance between the two charges. Now we will consider that these charges are very small, point like, so that we can position them in their respective position, and that is we can use our spherical symmetry, all this, so we don't have to think about any other complexity. So these are like point charges. So to start with, we'll consider the first charge, which is 0.4 microcoulomb, this is 4 × 10⁻⁷ coulomb, and another one is -8 × 10⁻⁷ coulomb. So if they come together, one positive and negative, then the field lines will change, not like this. These are the, you can see that these are the field lines. So this is going outward because it is positive towards infinity, and this is negative, so from infinity the field lines are coming towards the charge. This is the force experienced by a unit charge, that is we know as a field. Okay, and this is the line along which, the direction along which this force works. If you put some positive charge here, it will be attracted through this line, and this is true only if this charge is here. If these two charge here, then it will change. So I will show that at the end of the calculation, because now for simplicity I kept them like this, and we don't know how much they are distant, but we will calculate that. So let's suppose that the distance is r, and so the distance is r, and the force acting on them is 0.2 Newton. So to calculate or to find out the solution, we will consider the force equation of force acting between two charged particles, that comes from Coulomb's law, which is F is equal to 1/4πε0 q1 q2 by r square. Now here epsilon 0, we know that it is the permittivity of free space, which has this value, and for simplicity we will first calculate like this part, which comes around 9 × 10⁻⁹ Newton meter square per Coulomb square. Okay, so now we'll go to the calculation, final calculation. So for that, we'll again consider this equation, and if we rewrite this equation in the following form, that is r becomes 1/4πε0 q1 q2 by f. So here all this value, this r should be positive, not negative, because it is a length, and also it will not be imaginary, it will be a real number. So that's why we should take mod value of the charges, okay, whatever their values are, and also force. Right now we have taken positive, whatever value, whatever the parameters are, we will take their positive values, that is the absolute values. So by putting their values, we will get like this. So the r will be 0.12 meter. Now so their distance between these two charges is 0.12 meter. Now let's see how these two charges and their field lines look like if we put one positive, one negative charge. So q1 is positive here, so this one charge is positive and this one is negative. So the field lines are coming from positive and it is ending to the negative, and these are like going towards that, but it will again come here, this one, and meet here, and this will go towards infinity and then meet here. So this is actually a typical dipole looks like also. If you see two dipoles, or if you see one magnet, bar magnet, if the bar magnet has this size, like positive and negative, north and south pole, their field lines. You can find some similarity in the field lines. So thank you for your kind attention. Please hit the like button if you liked it. Share if you feel it can help others. Subscribe to get new videos. Thank you and keep watching.